Constructive plate boundaries. These occur where two plates are moving apart from each other. The crust is stretched, becomes thinner, and develops weaknesses. This can cause big gashes in the crust to appear, known as rifts. In the long term, as rifts widen, they get inundated by the sea, eventually creating new oceans such as the Atlantic, where the Eurasian and African plates rifted from the North and South American plate as Pangaea broke up. This plate boundary can be seen today running down the middle of the Atlantic Ocean in the form of the longest mountain range on the planet, the Mid-Atlantic Ridge. Rifting on the ocean floor often causes volcanoes to form, which create ocean ridges. Sometimes these ridges can build up to such an extent that they rise above the ocean surface to form islands. The most famous example in Europe is Iceland, which continues to be extremely tectonically active. But many islands in the Atlantic were formed in the same way. Tectonic activity in Iceland. Iceland is on a constructive plate boundary, so tectonic activity would be expected in the form of rifting and the associated ridges and volcanoes amongst the growing ocean. In effect, Iceland is part of the Mid-Atlantic Ridge, the underwater mountain range that runs all the way along the Atlantic Ocean from north to south, albeit a part of particularly high altitude. However, this doesn't explain why the crust is so thick at Iceland, and why it is one of the most tectonically active places on the planet in terms of construction of new crust. Tectonic activity is so active in the area due to a mantle plume underneath Iceland, bringing unusually high amounts of magma to the surface. In other words, the convection current is particularly strong as it moves from the deep mantle to the surface. It may be that it was the strength of this mantle plume that caused Pangaea to break up in the first place and create the Atlantic Ocean. Iceland sits on a geological hotspot. This means that the crust is particularly thin and the mantle with its magma is unusually close to the surface. Another reason for the amount of volcanic activity concerns the Jan Mayen microplate. When Pangaea broke up and the Atlantic began to open, there was a small microplate between the North American and Eurasian plates, the Jan Mayen microplate. By 50 million years ago, this microplate was located in the middle of the ever-expanding Atlantic Ocean. By 25 million years ago, the southern end of the microplate was subducting beneath the Eurasian plate, while on the surface, above the subducted crust, the North American and Eurasian plates continued to rift apart. Subduction and rifting inevitably caused a massive amount of volcanic activity and the formation of new land which would grow into Iceland. The subducted crust beneath the Eurasian plate also caused its eastward movement to accelerate. The different crust that is in contact with the mantle beneath Iceland means that the Eurasian plate moves eastwards faster than elsewhere along the Mid-Atlantic Ridge. This faster movement stretches the slower-moving crust nearby, making it thinner and causing new fault lines to appear. Along one of these fault lines, the West Men Islands were formed. The most recent of the West Men Islands is Surtsey, which started to form in 1963 when smoke from an underwater volcano was seen rising from the ocean by local fishermen. It stopped erupting in 1967, having grown to almost 3 kilometers square in area, and has become a very important place for the study of soil formation and the colonization by flora and fauna. The fast rifting at Iceland and the accompanying volcanic activity make it one of the fastest growing places in terms of land formation on the planet. The Jan Mayen microplate eventually merged with the Eurasian plate, but its legacy of enhanced volcanic activity and mountain building at Iceland continues. The eruption of Eyjafjallajokull 2010. Causes of the disruption. Phase 1. Eyjafjallajokull had started murmuring in 2009, and by 20th March 2010 was erupting lava. There was about 1 cubic meter of ice in the crater, and about 25% of this melted in the next 2 days, causing flooding in southern Iceland. Phase 2.
By 14th of April, the mix of magma and water caused a second phase of the eruption as a huge ash plume to extend as high as 10 kilometers into the atmosphere, with 750 tons of magma being ejected every second. Despite the very small size of the ash particles, most were less than 1 millimeter across. They were irregular and jagged in shape. This meant they weren't very aerodynamic, causing them to float in the air for longer than would otherwise have been expected. Changing wind directions caused the cloud of ash to extend over vast tracts of the North Atlantic, Europe, and beyond at various times during this period. Phase 3. By 20th April, all the ice had melted, and the plume was reduced to about 4 kilometers high, signaling a third phase of the eruption by the end of April. This involved a 500-meter fissure with spatters of magma creating fire fountains. Activity had now slowed down, but lava had already flowed several kilometers northwards by this time. Phase 4. By early May, volcanic activity increased again. There were earthquakes, and the ash plume rose again, fluctuating between 4 and 9 kilometers in height. This time, it wasn't the mix of water causing the ash plume, but explosive activity from gases dissolving into the rising magma. By 23rd of May, the volcanic activity had calmed down again. Effects. Short term. In the immediate vicinity to the volcano, the sun was blocked by the ash cloud, plunging southern Iceland into darkness and causing breathing difficulties for local people. Supplies of drinking water became contaminated, and 20 farms saw their land rendered unusable due to the covering of ash. The ash clogged up local rivers, which flooded due to the melting ice water, and important access roads were destroyed in places. Medium term. Particles of volcanic ash can clog up the jet engines used to power aeroplanes. For the 6 days, from 15th to 20th April 2010, airspace in and around northwest Europe was closed to traffic. Airports lost €100 million over this period, and the disruption caused a loss of €1.3 billion to the airline industry as a whole. Many cultural and sporting events had to be cancelled due to the transport problems. On 18th April, the state funeral of the Polish President Lech Kaczynski took place, and many world leaders, including Barack Obama of the USA, were unable to attend. 107,000 flights were cancelled, with 10 million passengers unable to travel. No goods are able to cover the costs of air transport, but for some products with a high value per volume, high perishability, and need to respond to demand quickly, air freight is often the norm. As a result of the disruption, there were shortages in electronic parts, components for the car industry, cut flowers, soft fruit, and pharmaceutical products. Long-term, local people continued to have medical problems, such as breathing difficulties caused by the eruption. The closer a person lived to the eruption, the greater the incidence of illness. There were some positive effects. Tourism to the area has increased due to its high profile, with Eyjafjallajokull now having its own visitor center. Although farmland was ruined in the short term due to the covering of ash, in the long term it has been improved due to the addition of rich nutrients added. Response. Primary. Local people and emergency service workers had to wear masks to protect against the ash and avoid breathing difficulties. 60 Icelandic Red Cross workers provided food, bottled water, and counseling for people affected, and several hundred people were evacuated. Ash had to be removed from rivers to remove blockages and increase river discharge. Frantic road clearing and reconstruction took place around the clock as the main road that encircles Iceland, the National Route 1, had been severed. Secondary. Unable to move goods by air, logistics companies were forced to find alternative, slower solutions involving sea and land transport. Travelers turned to ferries, trains, and different forms of road transport as an alternative to flying. Non-air transport reported big financial gains during this period, as demand for their services saw a massive increase. The comedy actor John Cleese paid €3,500 on a taxi to take him from Oslo to Brussels. By the end of April, the EU Transport Commissioner, Siim Kallas, eased the European competition rules to allow the national governments of member states to compensate airlines for their losses. Long-term, EU ministers agreed to integrate national air traffic control systems into a single entity, known as the Single European Sky. This also involved a new system for handling transport disruptions in the future. Research into volcanic eruptions and aviation has increased as a result, leading to more international cooperation. This has included more frequent measurements of air particles, the introduction of more accurate guidelines regarding the relationship between levels of volcanic ash in the air and its effects on jet engines, and when a no-fly zone should be declared. Iceland has now introduced a text messaging system so that people are given a warning 30 minutes
ahead of when volcanologists predict an eruption.